All right, so ladies and gentlemen, we're going to do trig functions, unit circle. So we're going to fill in our angles from 0 to 2 pi, from 0 to 360. Okay. So I like to do the quadrantals first and kind of show you guys the kind of common numbers that they have in common. Numbers that they have in common. So as I take a look, I got 0 and 360. So 0, 90 is pi over 2, so that's 1 pi over 2. And this is going to be 2 pi over 2, which is pi. Then 270 is 3 pi over 2, and then 4 pi over 2 reduces to 2 pi. Okay, so we got our 4, those are our quadrantal angles. Okay. After we do quadrantals, I like to show you the kind of resemblance of 45, 45, 90. So the 45s are multiple. We know what 45 is, right? Pi over 4. So 1 pi over 4. This is 2 pi over 4 reduced, because 45 plus 45 is 90. So again, this is 1 pi over 4, 2 pi over 4. The next one is 3 pi over 4. Then at 180, that's 4 pi over 4 reduced. Then 5 pi over 4, that's 225. 6 pi over 4 reduced is 270. 7 pi over 4 is 315. And then 8 pi over 4 is 2 pi. So if you look at the multiples of 45, the ones directly in the middle of each quadrant, 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 is the odd pi over 4s. Okay? So 1, 3, 5, and 7 pi over 4. Right. So last one, at least we got 30s and 60s. So if I look at 30s and 60s together, I always remember the first two. If it starts with a 3, then the fraction is going to have a 6 in it. So that's going to be pi over 6. And if it has a 6 in it to start at 60 degrees, then it's going to be pi over 3. So they're vice versa. So that's how I remember those. Is if it's got a 3, then the fraction's got a 6. If it's got a 6, the fraction's got a 3. Okay? Well, if I double 60, 60 times 2 is 120. If I take pi over 3 and double it, now I have 2 pi over 3. And if I double 120, 120 times 2, that's 120 times 2, 240. And if I double 2 pi over 3, now I'm at 4 pi over 3. Okay, so that's how I remember those guys. 150, if I take 150 and divide by 180, that reduces by, what, 30? So I get 5 pi over 6. So it's taking away a pi over 6. Okay? Here's 180. Now I add a pi over 6, so now I'm at 7 pi over 6. So this is 5 pi over 6, 6 pi over 6, 7 pi over 6. Okay. 5 pi over, these are the two that, you probably won't memorize. Okay, a lot of these you'll start seeing kind of relationships. So 5 pi over 3 is what, 300? And 11 pi over 6 is 330. Reduced by 30 there. Okay. So tomorrow we'll do some speed sheets with this. We'll usually do 16 questions. Most of them will be in the first two quadrants. And you'll start seeing those over and over, and you'll start remembering those faster and faster. And last year in Algebra 2, you probably were given this little pinwheel. Yeah, we can use it for homework and stuff, and on quiz or test, you got to just be able to convert. And again, with speed sheets, you're going to be like, oh, this is so easy. Most of you earn your extra credit for that. All right, guys, so now that we have our little quadrantals changed, now we're ready for goals 1 and 2, which is, again, find the exact values of our trig functions of quadrantal angles. Again, quadrantals are in between quadrants. So the multiples of 90. So 0, 90, 180, 270, 360. So we're going to find those trig functions, so, cut, and so. Then we're going to find the exact values of trig functions of 30, 60, 90, and 45, 45, 90 triangles. Okay. All right. So as we take a look, we know our trig functions from the other day. SOHCAHTOA. Make sure you spell it right. That's half the battle. And we know sine, S-O-H. That's for sine is O over H, opposite over hypotenuse. And we know cosine, CUH, C-A-H. C is for cosine, A is for adjacent over hypotenuse. And the last one, tangent, is sine over cosine. And if I do over H, A over H, the H is key, so it leaves you with TOA, O over A, opposite over adjacent. And we talked about the buddies. Remember, buddies don't start with the same letter. So tangent, cotangent are buddies. That's cosine over sine, which is AO, A over O. Not to get confused with IO. Cosine's buddy is secant. Remember, they don't start with the same letter. So C and S, S and C. Secant is 1 over cosine. That's the funny one. Ha! Just take A over H and flippy-flop. Last but not least is cosecant. CSC is cosecant 1 over sine. This is Santa's favorite one. Ho. Ho, ho, ho. H over O. All right, so we should have those down. We learn those in 8-1. Now, let's look at our quadrantal angles. For goal number 1, we're going to look at the unit circle. Now, last year, some of your teachers teach these quadrantals, again, 0, 90 degrees, 180, 270, and 360, and then multiples of that. Some of them teach it using just the basic coordinate point of the unit circle, using cosine comma sine, using 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And that's fine. If you remember that, you want to do that, that's fine. I always teach it using the 3 numbers for sine, cosine, and tangent in SOHCAHTOA order. Okay, so for SOHCAHTOA, at 0 degrees and anything right here in between quadrants 1 and 4 at 0, 360, 720, dot, dot, dot. I always remember these 3 numbers, 0, 1, 0. So that's what I use right there. Okay, so what does that mean? Just means that sine of 0 is 0. So 0 degrees. The cosine of 0 degrees is 1. And the tangent of 0 degrees, or 360, or 720, or what have you, is 0. So that's what these 3 numbers represent. It's giving you sine, cosine, and tangent for those. Okay? So up here, at 90 degrees, again in terms of SOHCAHTOA, the numbers I remember here are 1, 0, and U, where U is referring to undefined. When you start looking at graphs for tangent, you'll actually see those vertical lines that your graph gets closer and closer to, but will never touch. You guys remember what those are called? Watch your mouth. Yes, the old asymptote. You'll see asymptotes for tangent. Okay. So again, what this means, guys, is the sine of 90 is 1. The cosine of 90 degrees is 0. And the tangent of 90 degrees is undefined. So that's what that IOU stands for. So I got 0, 1, 0, and IOU. When you guys move to the other side, this just gets flipped over here, and the numbers are the same. It's 0, negative 1, 0 now. And this is IOU, 1, 0, U. I call it IOU because it looks like an I, O, and U. This is now negative IOU. And again, that's in terms of sine, cosine, and tangent. So down here, the sine of 270 is negative 1, the cosine of 270 is 0, and tangent of 270 is undefined. So that's the numbers I'll use. I'll put that on the sideboard for you guys later. We'll have it up for the next few days here. Okay. Now, if you ever forget those, you just throw it in your calculator. If I want to know what the sine of 180 is, throw it in the calc and you'll get 0. All right, do we have those written down now? So 0, 1, 0, IOU, negative IOU, and 0, negative 1, 0 for them. All right, so as we take a look, that takes care of your quadrantals, and we'll use those later. And now I want to take care of the 30, 60, 90 triangles, okay? So first things first, you'll notice that I have these angles listed so that the angles get larger and larger. So 30, 45, 60, and 90. And as the sides get bigger and bigger, the angle gets bigger and bigger. And vice versa. The angle gets bigger and bigger, the sides get bigger and bigger. Okay? So as we take a look over here, this is the smallest side. That's across from the smallest angle. This is obviously the 90. That's across from the hypotenuse, and that's 60. Over here we have that isosceles triangle, 45, 45, 90. So this guy's 90, and these are both 45 degrees. If you want to fill in the radians, you can. Again, this is pi over 6, pi over 4, pi over 3, and pi over 2. I'm not too worried about the radians. Most important thing is getting the sides correct. Okay. So as the sides get bigger and bigger, the angles are getting bigger and bigger. So across from the smallest side is the smallest angle, which is the square root of 1. Simplify. What's the square root of 1? 1. So across from 30 is always 1. 45 is the square root of 2. Square root of 2 doesn't simplify, so I leave it, the square root of 2. Well, the next square root would be the square root of 3. So across from 60 is the square root of 3. That doesn't simplify, so I leave it at root 3. And last but not least, the square root of 4 is 2. Okay. Now, I always get that one thing like, hey, that's not what I learned last year. This is what you learned last year. This might be different, and I'll explain on why my triangle might be different than what you learned last year. Okay. Some teachers use the unit circle approach. I'm using the Gotch approach, where they use the 45, 45, 90. And what they'll say is that this guy here is 1, and this, that this guy's 1, and this is root 2, sorry. So that guy's 1, 1, and root 2. Okay, well, you can do that. What I'll do is, because we see sine and cosine so often, where we have to do opposite of hypotenuse, that requires a lot of rationalizing. So what I'll do is, I'll multiply this guy, and this guy by root 2, so I don't have to rationalize all the time. So root 2 times 1 is root 2, that's root 2, and that root 2 times root 2 is just 2. So I'll rationalize that triangle, and that way it's taken care of. The other reason why I do that is because I don't want you guys thinking about what is my hypotenuse. Is it a 1 or is it a 2? That's just too much thinking for you guys. So now you guys know, if you're using my triangles, they are always 2, your hypotenuse. Always, always, always. Always going to be positive 2. Okay? Versus, is it a 2 or a root 2? I can't remember. Okay? So this is less thinking for you guys. Okay? Plus, if you list your angles in order, root 1, root 2, root 3, root 4, and simplify as you need, makes it pretty easy too. Okay? All right, so here we go. Let's get started. I got the sine of 45, sine of pi over 4. Sine of pi over 4, I always have you guys convert that to degrees. I think it makes it easiest for you guys. What's pi over 4? That's 45 degrees. Again, you get really good at that. If you need to, go off to the side, multiply so that the pi's cancel. Pi's cancel. 180 divided by 4 is 45. Well, sine of 45 is just saying, hey, I need O over H. Now, some of you guys might know the answer already, which is great, but quiz or test, I want to see the work. So off to the side, we make a little 45-degree angle. I always use X and Y coordinate system. So I always recommend drawing your X and Y axes. I make a 45-degree angle This is my initial side. This is what we learned yesterday. This is my terminal side, and that's 45 degrees. We make a triangle now, a right triangle. When you drop down the other side, the opposite leg will always make a 90 with an x-axis. Never, ever, ever draw to the y. Why? Because Mr. Gotsch said you will be so messed up if you do that. Always to the x. And now we have a 45, 45, 90. And we just learned across from 45s, we set our root 2s. That's a root 2. And across from the 90 is a 2. Okay? Last but not least, we need to find sine, O over h. The angle that you work from will always be nearest the origin. And then we need O and H. Which one's O, which one's H? Which one's opposite, which one's hypotenuse? I know our hypotenuse. Yeah, this one's opposite. Opposite, guys, will always be up and down. Adjacent will always be on the x-axis. So final answer, I get root 2 over 2. Exact values, guys, is what we're looking for. I will always get that one guy that will give me what they find in their calculator. They'll show no work and be like, oh, Mr. Gotsch guy's crazy. Who's going to do this? Sine 45 and you give me this answer. You're right, but it's not exact. Okay? Number one, I got to see the work. Number two, I need this answer, root 2 over 2. I can check my work using my calc, doing root 2. Let's delete that. Get out of there, and then divide by 2 on the outside, and there we go. So that does work. Good way to check your work, but not how to do the work. Okay? So final answer, root 2 over 2. All right, so again, exact values, no decimals, please. Show your work, show your triangles. On the test, they'll say, show your triangles or circles. All right. Any questions, y'all? You guys did this in Algebra 2. This is, again, now the second time you've seen something like this. Here we go. Cosine, 5 or 6. I always convert that. What's 5 or 6, y'all? 30. If it's got a 6 in it, the angle's going to have a 3 in it. So in this case, 30. So I want cosine, ca, is A over H. So I got to go off to the side and make my little triangle. So this guy here is 30 degrees. I drop down the 90 to the x-axis. And we label our 30, 60, 90 triangle with our sides. What's across from 30? 1. What's across from 60? Root 3, and the hypotenuse is always positive 2. Angle that you work from is always across or next to the origin. Nearest the origin. Never, ever, ever over here. Always nearest the origin. And I wish you could tell I'm using different colors here, but across from this guy is the opposite. This is our adjacent and hypotenuse. So final answer, what's the cosine of 30 degrees? Adjacent is root 3, hypotenuse is 2. Done. Any questions there? That's not so bad, right? Who remembers doing this? Happy here? Yeah? Alright, so this is good practice. Back and track. I'm not going to do all these today. We're going to cut you down here. That's example 5 for today. So as we take a look, I got tangent of 7, 5, or 6. Go ahead and convert that. That is the tangent of what? If you need to, go off the side, 7, 5, or 6. Multiply by 180 over pi. Pi's cancel. 180 divided by 6 is 30. 30 times 7 is 210. Right? I want TOA O over A. So, TOA. So off to the side, I make my little triangle. What quadrant am I in now? Where's 210? Quadrant 3, right? Is that what I heard? So
this is 210 here, guys. Now, if this is 180 and this is 210, the most important angle that I create, again, I always make my 90 with the x-axis. The most important angle I got to figure out is this angle right here. If this is 210 and that's 180, what's that angle? What's the difference between 210 and 180? 30. So if you say 60, now you're going to put your root 3 and 1 in the wrong spot. So that's the most crucial angle that you create. Okay, you just find the difference. What's 210 minus 180? We know that's 30 degrees. Okay, I'll zoom in so we can see this little triangle here. Alright, so if that's 30, we know this guy's 60. We know the hypotenuse is 2. And then across from 30 we know is 1. And across from 60 is root 3. Okay, now, anytime we're plotting outside of quadrant 1, we got to think about how are we plotting this point. The point that we're plotting is this point at the edge of your terminal side. So think of a dot right here. If I was plotting this corner point, I'd be going left and down. So what does that mean for opposite and adjacent legs here? If you go left, what does that mean? What type of numbers are to the left on the x-axis? Negative, so this guy's going to be a negative. And if I go down, that's also a negative value. So that's a negative 1 there. You guys okay with that? Alright. We need opposite and adjacent working from this guy. By the way, guys, hypotenuse will always be positive. Always positive. That will never change. It's only opposite and adjacent could change their sign. Alright, which one's opposite, guys? Well, which one's opposite? Negative 1. So this is the OPP. Which one's adjacent? Well, negative root 3. This is 0 adjacent. Very good. Alright, am I done? Do a little simplifying. What's the negative divided by negative? That's a positive. So go ahead and change those guys to pluses. And if you leave it like that, you're a dirty rat. I would circle this and write rat on your paper. It's not because you're a rat, it's because I want you to rationalize it. Go ahead and multiply top and bottom by root 3. So 1 times root 3 is root 3. And what's root 3 times root 3? 3. So the final answer we'll get is root 3 over 3. Okay, quiz or test, you want to check that if you can. Should get a positive root 3 over 3. What is it down? Do 2 more. How about that? Alright, example 4. Here we go. I got secant of 2 pi over 3. I always convert. What's 2 pi over 3, y'all? 120. Do you have to? No, you don't have to. Some teachers just leave it in radians. I mean, for you guys, it helps visualize what's going on here. Where are we going? What quadrant is 2 pi over 3? What's 120 degrees? I know where that's at. 120 is in quadrant number 2. So initial side to terminal side is 120 degrees. Okay? Drop it like it's hot. Drop it like it's hot. Drop it like it's hot. To the x-axis, y'all. Always. The guys and gals that struggle, they go across. They don't drop it like it's hot. You gotta drop it like it's hot to the x-axis, or oh man, it's gonna be bad. Okay? Most important angle you guys come up with is this guy right here. Well, across is 180, right? This is 180. If that's 120, these have to be a linear pair of supplementary angles that add up to 180. So take 180 and subtract 120. What do you guys get? That's a 60-degree angle. So if you say 30, 120 plus 30 is only 150. It's not enough. It's got to be 60. Okay. That guy's 30. And across from 30 is 1. Across from 60 is root 3, and hypotenuse is always positive. 2. Now again, think about, before we figure out secant, think about plotting a point at the very tip of this thing, at the tip of the terminal. I'd be going left and up from the origin. If I go left, that means this guy's negative. And if I go up, that means that guy stays positive. So this should be a -1, a root 3 and 2. All right, secant. Came with secant. SOHCAHTOA. What are my two sides I'm looking for? Is this one Santa's favorite one? Or is this the funny one? Hypotenuse over adjacent, H over A. Perfect. We know the hypotenuse is 2. Always, always, always. This guy's 2. Which one's adjacent? Lauren, which one's adjacent? -1. Adjacent guys will always, always be on the x-axis. Okay, so -1. If you want to simplify, that's just -2. Final answer. Okay. And again, secant has 1 over cosine. So if I do 1 divided by cosine of 120, there we go. I get -2. Okay, so I can check my work. Alright, last but not least for today. Let's giddy up with example number 5. Let's find the exact values of each expression. Do not use a calculator unless you're checking work. Or if you need to convert radians, degrees, radians, you guys are so good. You guys don't need to do that. What's 5 over 3? 60 degrees. Okay. So I need to go make a 60-degree angle, and then make my triangle, and find TOA, tangent, and cosine, CA. So off to the side, and go ahead and work on that. 60 degrees we know is in quadrant number 1. Drop it like it's hot. So that guy's 60. That means this guy up here is 30. Cross from 30 is what side? 1. Cross from 60. Root 3, hypotenuse is 2. So again, you always work from the angle closest to the origin. This guy is your hypotenuse. This is your opposite. This is your adjacent. So far, so good? All right, Dane, what's tangent? What's O over A for this one? Yes, sir. And A over H. Cosine. Mary, what do you got for A over H? Cosine. What's that? There you go. Perfect. Alright, now if you do this on a quiz or test, I would accept this, me. Okay? But my math guy might ask you guys to simplify it. Okay? So they might ask you, hey, put it as 1 fraction. So the idea is they're trying to get you to put this together. Okay? So I need common denominators. Right? So what is this guy missing? A 2. So multiply top and bottom by 2. And I'll get 2 root 3 plus 1. And then all over 2. For me, I would accept either or. I'm fine with this. But my math lab might require that. You guys do what I want.
All right. So as we take a look, we're working on example 6, y'all. It says find the exact values of each expression. Do not use a calculator. Now you can use a calculator to check your work, but let's do that at the end. So the first thing is we have pi's over 4s, right? Speed sheets say we need to be able to convert that real quick. So I always convert to degrees. So what is pi over 4? What do you guys get? What is it? 45 degrees. So I'm going to go ahead and change those to 45s. So again, if you need a refresher, because we're going to do some speed sheets later, if I have pi over 4, we need the pi's to cancel. So multiply by 180 over pi. Pi's cancel. Now, 180 divided by 4 is kind of hard. But 180 divided by 2 is pretty easy. What's 180 divided by 2? 90 divided by 2 is 45. So if you divide by 2 and divide by 2 again, that's dividing by 4. Makes it pretty easy to do. Okay, so 45 degrees is what we got. Okay. Well, again, we want SOHCAHTOA. We want sine, which we know is O over H. And we want tangent, TOA, which is O over A, of that 45-degree angle. So we're going to go off to the side and go ahead and do that. So here we go. 45 degrees we know is in quadrant 1. So there's that 45. Okay. So that's the first thing we did in 6.1 is just graph an angle. Now we're going to make a right triangle. Now, do you graph it so that you connect it with the y-axis? Oh, no, no, no. No, sir. No, ma'am. Drop it like it's hot. Drop it like it's hot to the x-axis. Make that 90 with the x. And now we have our 45, 45, 90 triangle. For my triangles, what's across from 45s? Root 2. Root 2, and hypotenuse is always a positive 2. We're always working from that nearest angle, nearest the origin. So this is the hypotenuse. Which one's adjacent? Which one's opposite? Which is which? Which is adjacent? Yeah?
The root 2 on the x-axis.
Yes, so on the x-axis will always be adjacent no matter what quadrant you're in. So A is always on the x-axis. Axis is your A. And then opposite is always the up and down one, the OPP. So we want, so good job, Bri. We need opposite and hypotenuse. We know that is root 2 over 2. And then we need opposite over adjacent. That's root 2 over root 2. So we do a little simplifying. If I take 2 times root 2 over 2, the 2's cancel. Gives me root 2. What's root 2 divided by root 2? Those cancel, give me 1. And that's it, guys. There's nothing else I got. I got root 2 plus 1. That's my exact value. Now, quiz or test, I want to make sure I get this right, so I'm going to double check my work. So that's where you can use your calc. Okay. Now, for me, I have my calculator still in degrees. Okay, so I'm going to use 45 degrees. If you have it in radians, then use the pi over 4s because that's in radians. Okay, so I'm going to type this guy in like I see it. I've got 2 sine of 45, close that parenthesis, and then plus tan of 45. And we get this decimal, I got 2.414. Well, if I take a look, the square root of 2, move your directional pad to the right to get out of there, plus 1 should give you the same thing. Yes. So now I know I did it right. Okay. So you can use your calculator check work, but that's not how you do your work, unless you need to help convert from radians to degrees. Okay. Any questions, y'all? All right. 7 and 8, we're just going to do number 7. So we're working on finding our exact values of the 6 trig functions, so SOHCAHTOA, TOA, and their buddies. And the first thing I always do is convert this guy. 3 pi over 2. What's 3 pi over 2? How much is that? What's 180 divided by 2? 90 times 3 is 270. Speed sheets, it's 270 degrees. Now, at quiz or test, we always ask you guys to draw triangles or circles. Well, 270 is a very special case. 270 will put you right here. 90, 180, 270. That's 270 degrees. Okay? So this is not a triangle, guys. Don't try to draw a triangle like this. This is a quadrantal. This is a special case. The quadrantal, in between the quadrants, is a circle. And yesterday we talked about knowing your 2 points up here, so you know the 2 points down here. So we talked about SOHCAHTOA, 0, 1, 0. That's sine, cosine, and tangent of 0 degrees, or 360. And we talked about this one is IOU, SOHCAHTOA, sine, cosine, tangent of 90 degrees. Okay, well, 270 is down here. If you know this one, this is 0, negative 1, 0. And if you know this one, that's negative IOU. So this is the one we're looking at. Again, this is in terms of SOHCAHTOA. So then we should know the sine of 270. What's the sine of 270? Negative 1. We should know the cosine of 270. Cosine of 270 is 0. And tangent of 270, what does the U mean? Undefined. UND for short is fine. Okay. Eventually we'll talk about that graph. You'll see an asymptote up and down at 270 or 3 pi over 2. Okay. Now they also want this, all 6 of them. So we got sine, cosine, tangent. Now we need the buddies. Okay. First off, sine. Who's sine's buddy? Cosecant. Remember, buddies don't start with the same letter, so it's not S and S, it's S and C. Now, the reason why they're buddies is because they're inverses of each other. They're reciprocals. So cosecant is 1 over sine. I'm going to use theta instead of 270. Same idea. And that's 1 over what? What's sine of 270? Negative 1, which is negative 1. Okay. So if I know sine, just do the reciprocal. You get 1 over negative 1, which is negative 1 for his buddy cosecant. Okay. So I do the next one. Cosine, who's his buddy? Secant. The reason why they're buddies is because it's 1 over cosine. So if I take 1 divided by 0, what's 1 divided by 0? What's 1 candy bar divided by to your 0 friends? Oh, you can't do that. Plus, it's sad you have 0 friends. Undefined. So that's a big deal here, guys, is if your one guy is 0, his buddy will be undefined because it's going to be 1 over 0. And vice versa. If one is undefined, then his buddy is going to be what? 0. Cotangent. Okay. Now, why? Everybody wants to know the why. Okay, well, tangent is sine over cosine. Sine of theta over cosine, which is, in this case, negative 1 over 0, which is why that's undefined. Cotangent is the reciprocal of that. That's cosine over sine, which in our case is 0 over negative 1, which is 0. So that's why that works. Okay. So if you, big idea though, I never do all that work. I just know if one guy is 0, his buddy's undefined, and vice versa. If one's undefined, the buddy's 0. And that's because they're flipping it. It's going to be 1 over 0 and 0 over 1. Okay. All right. Do you have any questions? Now, I usually skip example number 8, but I like to talk about it. Okay, so I'm not going to do example 8. I just want to talk about what would you do if I asked you to do 11 pi over 4, because this is actually something we talk about in the next section. First thing is convert this thing. 11 pi over 4 is how many degrees? If you need to, multiply by 180 over pi. Pi's cancel. And this turns into 45. 180 divided by 4 is 45. 45 times 11 is, you might need your calculators. 450 plus 45 is 495. Whoa! That's pretty stinking big, right? Well, 495 is way past 360, right? Well, it's a circle, right? It starts replicating after 360 degrees. Okay, so if you think about it, 495 is just the same as what? If I subtract 1 revolution around, I get 135. That's called a coterminal angle. So that's 135. Okay. So if you're going around 360, and go again, that's going to give you the 495. That's going to put you exactly in the same spot. So if you know sine, cosine, and tangent of 135, then you can figure out the sine, cosine, and tangent of 495. Same, you're going to get the same thing. Drop it like it's hot. And the biggest angle you got to come up with is this little acute angle. What's this little acute guy? The straight line is 180, so if 135 minus 45, or 180 minus 135 is 45. And then from there we got a root 2's, 2, and then this one is to the left, that's negative root 2. So from there we should be able to find sine, cosine, and tangent and their buddies. I just want to talk about what to do if that angle is bigger than 360. Just subtract 360 until you get an angle between 0 and 360. So if you get a really big angle, like 900, subtract 360, subtract 360 again, and you should get something between 0 and 360. Okay, that's called a coterminal angle. We talk more about that in 6.3, so I'm not going to spend much time on it. I do want to talk about example number 9, then we got some calculator tricks for you. So example 9 says find the exact value of the 6 trig functions. These are going to be similar to problem 73 through 82. So when you guys are doing your My Math Lab, up in the left-hand corner, it will have a problem set, which is like what we see in the textbook. Okay, so when you're doing, you know, at the end of your My Math Lab assignment, you'll start seeing 73 through 82. Well, this is what you do. They're going to give you a coordinate point, negative 3, 4 in this case. Okay. And what we want to do, I'm a visual person, you're probably a visual person, so just go ahead and graph this thing. So negative 3, 4 is in what quadrant? The second quadrant. So go ahead and graph it. 1, 2, 3, and then up. 1, 2, 3, and 4. It's right there. Okay. Well, what you're doing is you're creating a right triangle with the x-axis, and then make a terminal side right there with the origin. Okay. So we went over 3 to the left, that's negative. We went up 4, bless you, and we're going to have to find SOHCAHTOA. We got to find our SOHCAHTOA, so that means we need our hypotenuse here, because that's our 90. So hypotenuse, what's this guy? How'd you do that? It's a 3, 4, 5 Pythagorean triple. If you don't know your triples, that's okay. Just use Pythags. A squared plus B squared equals C squared, or Pythagoras theorem, as we like to call it. So if you need to, negative 3 squared, anytime you take a negative and you square it, you always get a positive. 9 plus 16 is 25, and when you square root that guy, you get your 5. Just know your 3, 4, 5s, and it makes it pretty easy. From there, we can find our SOHCAHTOA. We're going to find the sine of this angle, theta. Don't know what it is. Don't care what it is. I just need the sine of that. Then I need the cosine, and then I need the tangent. All right, SOHCAHTOA, what's sine? Who's got O over H? Working from this angle, I'm assuming we know this is hypotenuse. What's 4? That's opposite. And negative 3 is the adjacent. All right, so Nick H, what do you got for sine? 4 over 5. Who's his buddy? Who's his buddy? Yes, sir. And that's the Santa's favorite, H over O. That's 5 over 4. Perfect. So if you do sine, I do his buddy right away. Just makes it easier. Okay. Cosine, Jack, what's cosine? Who's his buddy? Secant? There you go. That's the funny one. Ha! Just flip that thing over. What do you get? There you go. Negative 5/3 or 5 over negative 3, either way. Perfect. Last but not least, we got tangent. James, what's tangent? What's TOA? So negative. So opposite over adjacent, so negative 4/3. If you have 4 over negative 3, it's the same fraction, just different place to put the negative, same thing. And then cotangent, what's cotangent? Ayo. Negative 3 over 4. Negative 3/4, either way, perfect. Okay, so if they give you a corner point, go ahead and graph that corner point. Essentially, guys, this is going to be your adjacent leg. That's going to be your hypotenuse. And then from there, or excuse me, that's your adjacent leg. That's your opposite. So negative 3 was our adjacent. That's our opposite. From there, you got to find your hypotenuse. A little Pythagoras should be easy to do. Okay, or it might be a triple. Okay. Last but not least, any questions on 9? Last but not least, use your calculator to find the approximate value of each expression. It says sine of pi over 11. First thing I do is identify what type of angle I have to be in. If you see a pi, that means I have to be in radians. So that's when I check my mode. If I see a degree symbol, I got to be in degrees. So I check my mode, put this thing in radians. So mode is up here, right next to the second button. Go down to radians, click enter. Now it's highlighted, I'm in radians. All right, so I want to type in the sine and then pi over 11. Where's pi on your calculator? Yeah, the raised 2 button, the little caret, I call it. Well, raised 2. So second raised 2, and oops, try that again. Second raised 2 divided by 11. If you want to close that, you can. You don't have to on this one. It says round to 2 decimal places, so 0.281 is approximately 0.28. All right, questions? Now the next one is cosecant. So if you can do sine, you should be able to do cosecant. The problem is cosecant's not on the calculator. So you got to know who's his buddy. Who's cosecant's buddy? Sine. So again, if you look and look, guys, you will not see cosecant. Now, some people will think it's second sine, and that's the inverse, not the reciprocal. That's different. Second sine is the inverse of sine. That's what we use to find the angle. Well, they gave us the angle. We want to find the ratio of sides. So as I take a look, this is just 1 over his buddy, the sine of pi over 11. So literally do 1 divided by the sine of pi divided by 11. Do not touch the angle on the inside. Don't flip that guy. That's not right. Okay, that's an angle. I can't change the angle. We should get 3.549. The 9 rounds up to 55. 3.55. And that's it.